everyone. Welcome to the Carlson webinar for Drone Topo Survey with Carlson PhotoCapture and Precision 3D Topo 2018. I've got with me today Nathan Cruz, who is the lead programmer for Precision 3D Topo. I've got Ben Vanderjagt. Yes, with us too. He is Carlson Precision or Carlson PhotoCapture, one of the head people there, and myself, and I'm Mark Long. I do a lot of Precision 3D, civil, and hydrology for Carlson software. So, Nathan, if you're ready to start.
Yep, I can. I'll go ahead and take it away. So, what we're going to do is start you off briefly in Precision 3D Topo, just to prepare the ground control data. In this particular case, what we did was we imported an ASCII text file into Precision 3D after we set our projection. So here we're in this particular data set, we're working in NAD 83 Michigan South, so a U.S. state plane, and we are working in meters today. So the one thing, once you import your data, whether or not it's a Carlson CRD file or you have a land XML file or a coordinate ASCII file, from other vendors, it's basically you can import these variety of coordinate point files. What you want to do is make sure that you set your projection on your current scenario to your project area, the one that you want to process your photos in on PhotoCapture. And then you also want to make sure that you set your units of measure to match. And so in this case, I'm going to switch it all to meters. And so at this point, then basically, once I've imported my CRD data and I made sure that my projection, my units of measure are all set, then basically all you do is export the land XML file. And I'll just call this one number 2. And what that does is that produces a file that contains not only your ground control points, but most importantly, it's got the units of measure, and it also has the coordinate system burned in. So the projection is now burned in. And when you see Ben start to work with the land XML file, you'll notice that he just drags and drops and things happen automatically. So once you set up your coordinate system and your units measure or your projection system here in P3D, you basically, that's the only time you have to set it. And you could just, the rest of the workflow, we automatically read the units of measure and the projection back out of the LAS file when Ben's done with it. And so we try to make that just as easy as possible. So we can also verify the location, in here by tool tipping and all that kind of stuff to make sure we're in the right spot. But in this case, I know that we are in the right place. And so with that, now I will hand off the land XML file to Dr. Vanderjagt and let him show us Carlson PhotoCapture.
So just to give you an overview, here is the access point for PhotoCapture. So PhotoCapture itself, in its current iteration, is a fully web-based platform. So rather than having to invest in heavy-duty computers, all you have to do is create an account at photocapture.carlsonsw.com, and you should be able to go and start processing imagery from your drone or UAV. Okay, so all you have to do is click on Launch here, and we're going to launch the PhotoCapture platform. So just to give you a quick overview of how this works. So you can see here that on the left-hand side, I have a control panel, and I've got create, sites, account, support, etc. Okay. So to get started with the with our sample project today. We're going to click on Create. And now let's add in our data for today. Okay, so we're going to call this webinar test run. And now all we have to do to get our project started is we're going to go find where the images are. So you can either drag and drop or you can browse. In this case, I'm actually going to use the browse option. Select all my photos in the control. And here we go. Okay, so now we're off and running. So I'm going to call this test project. You can see here that we automatically determine the coordinate system that this project is associated with, but you can also change this. So in this case, I'm working in Michigan South, but let's say I wanted to go to international feet because I'm surveying in Michigan and I want to use international feet. You can see here that we automatically will update the projection information just by changing from units. Okay. Now, if we want to go back, we'll do the same thing. And one last option as well. If you did want to change, let's say you wanted to work in Michigan North for some reason, you can just come here, start typing in Michigan, and there's a fuzzy search that allows you to select whichever coordinate system you'd like. So in this case, I'm going to stick with Michigan South. And at the bottom here is something called Add to Existing Site. And I'll talk more about that in a little bit. We're going to leave that blank for now, and we're going to scroll down. Okay, so here's our map overview. A couple features to be aware of. If you wanted to, let's say you had some photos over a lake, for instance, or you wanted to split up your project, you can come up here to the right-hand corner here and select Crop Tool. And if I wanted to select just a subset of all of my images, I could do that with the Crop Tool. And as you can see here, it's only selecting the blue ones to be processed and not selecting the red ones. In my case, I do want them all though, so I'm going to click on that again. I'm going to select them all. And here I've got all my images. And you can verify that just by, you can see here that you can switch between map and images and see which images are being used. So we're going to click on Upload since we've already added our ground control. One last thing while we're on it. In my case, I already had existing ground control. I had an existing control file. So I had a land XML file and I have a text file. But if you wanted to, I'll show you one more option for adding in ground control. Okay. So if I wanted to, I could do a manual import. And in this case, I'm going to select northing easting. I'll select my unit of measure, and then I would select my coordinate system. And as you can see, it's the same type of process. So if you want to manually input your coordinates, you can do it this way as well. I'm going to click on Cancel, and we're going to upload. Now, before it uploads, it might give me a few warnings. So basically, these warnings are in place just to let you know if your control points are a long ways away from your images. Because what we've seen is that sometimes projections get set incorrectly, or you're using control from a different project. And so that's what this warning is here for. In our case, it's only warning us because we're only using a subset of the original images. So I'm going to click on Upload, Continue. You can see here that there's a confirmation tab, and I'm in Michigan South. I'm using unit of measure as meters. If I go down here to the Advanced Fields option, you can see here there's a couple advanced features for people who might be utilizing a PPK system, for instance. So if you're using PPK and you know the accuracy of your flight GPS or your geotagged photos is accurate to 2 centimeters, plus or minus 2 centimeters, you can include that here. Generally speaking, most people don't use the advanced features, but you can configure a lot of different aspects of your project in this location. So let's click on the coordinate system and unit of measure above our correct, and now we should be good to create our project. Okay, so now that we've created our project, you can see here that this is a web-based platform. So you have to actually upload the images to the server, and then the server is going to crunch through that data as rapidly as possible. Okay, so once the upload is complete, you'll see here that the different products are started. And sometimes it takes a minute or two for that compute, that cloud instance to spin up and start crunching on your data. But usually it's very rapid, usually within 1 to 1.5 minutes. Okay.
So Ben, where does PhotoCapture run right now? Where does it run?
PhotoCapture currently runs on Amazon Web Services.
And so if I upload something with 500 images as opposed to 16, what is the performance difference like? So if I do a bigger project.
Yeah, that's kind of the benefit of using the web platform, is that we scale based on how many images you upload. So if we see that you're uploading 1,000 images instead of 10, we automatically scale up the computing resources that are needed to really process that project quickly. Okay, and so in that case, we can turn around data sets much faster than you would if you were processing on your desktop. One other benefit. So if I had 3
projects going, right? We could
exactly. That's the other benefit, is that what we're seeing is a lot of people will fly. Let's say you're working a mine and you're doing volumetrics for a series of mines, and they just want quantities at the end of the month. What we see is that people will fly all of their projects within 1 or 2 days. And the benefit of the web platform is that you can upload them all simultaneously and they'll start processing simultaneously. So you don't have to worry about doing a sequential processing. That's all taken care of for you. Okay, now let's go and take a look at a couple examples here that we've gotten. So if we go here to this most recent project that I created, we'll click in at day 1. So you can see here's my image upload. If we go and click on the dense point cloud, we can see here that, oops. Sorry guys, like I mentioned, I did this at the very last second, and I had to find a laptop that that worked with GoToMeeting here. And so I found an old dusty laptop in my apartment, but it looks like the software is out of date from a web perspective. Nathan, do you want to take over and show off some of the 3D viewing capabilities?
Certainly, I will do that. So let's see, this is the new gravel pit. So this is the area in question. And I'm going to go into the dense point cloud viewer. And this environment, so basically your right mouse button, hold it down to rotate, the scroll wheel to zoom in and out, and the left mouse to basically pan around. Very simple, easy to use controls. And once we're in there, you could do things like measure. So we can do distance measurements. We can also do area measurements and even cut a profile. So if we wanted to cut a profile here, zoom out just a smidge. Cut a quick profile across this little pile here that we have, then you can do that. So you have some basic tools here for measuring areas and angles and distances and such. And this is also a way, so if you go into the admin setting on your project, you can set up email addresses for your clients or your customers so that they can log in and basically look at all of the data products from their smartphone or their web app, so that they can actually review, the data that you've collected and processed for them. If you're going through some sort of approval process. So all you would do is just type in their email addresses and add them in there, and they'd be able to see that. So we also have a nifty surface viewer. And for those that missed it, it's a very Google Earth-esque sort of experience, where you're way out on the site, and then basically it zooms into your project area, which is the area that we're in right here.
And it might take a couple seconds to load in those textured 3D surface tiles.
Yep, so we'll just let it kind of rest there for a second. And again, the nice thing is that this will run on a tablet, smartphone, whatever platform that's convenient, for your customers. So they're probably not running engineering workstations and that kind of thing. So this is a really nice option, because your projects are hosted on the PhotoCapture website, hosted in the Amazon cloud, and it's there essentially in perpetuity. You can also download all the data products locally. So basically, this is the data loaded in and draped over our Earth model here.
And it's a 3D texture. Do you want to rotate it and sort of show the?
Yep. So you can see just how nice this meshes, and the level of detail is very high in here. I think in one of these areas, you can actually see footsteps, somebody walking up the side of one of these piles to go set a ground target. So very detailed, very, very detailed, and a nice representation of the actual project. So, and again, this is just a great way for you to review the data before you download it, allow your customers to do the same thing. And then another nice feature is, so we have all these built-in viewers. You can also request more products. So if you want to reprocess that point cloud in a different unit of measure, different coordinate system, you can reprocess the same data without having to upload any more images, which is the thing that counts against the bandwidth usage, right? It's only the image upload bandwidth that counts against the usage, when we charge by the gigabyte. And so it's only the image upload. You could process as many data products as you want and download as much or as often as you need to, and that doesn't cost you any more money. And so that's some of the sharing stuff. And then again, you can also share your projects with other people in your organization as well. Yes.
If you don't mind, I was gonna go back and show them the GCP interface, since I have that available right now.
Yep, so now we'll switch back to Ben.
So once again, I apologize in advance. Well, I apologize right now because, like I said, I had this old laptop, and I just patched it together before this meeting. But here is the GCP interface for the project that we just uploaded on Carlson PhotoCapture. Okay, so the way it works is when you upload your images and control points, we do an initial 3D reconstruction, and then we predict where those ground control points should be. And you can see here that we're usually within about a meter of where the control point actually is. And this is due to the fact that on the UAV, on the drone, those GPS positions are usually only accurate, to 2 to 5 meters. And so we're usually within a meter. So what I'm going to do here, this is how you'll use ground control points in your workflow to tie in the photogrammetry data to the survey datum that you're currently working in. So I'm going to click on the center of that target. And you can see here on the right-hand side that that we have something. We have accept or skip. In my case, I've got a clear target, so I'm going to accept it. You can see here that when I accept it, it says corrected in the upper right-hand corner. And now I'm going to go to the next GCP. So in this case, you can see here, once again, I'm off by about a meter or so. So I'm going to zoom in, click on the center of that target, hit accept, and I'm going to keep doing this. Okay, so I'm just going to do that I usually do it for about each GCP. I'll click on maybe 2 or 3 times. So in this case, there's 3 appearances for this one GCP, and I'm going to click on them. And then this is the last GCP that I'll click on. But the idea is that rather than manually scrolling through all of your images, we only show you the images where your GCPs are visible, and we're very close to where they should be. So you don't have to spend a lot of time thumbing through your images trying to find it. You just simply click on the target and move on. Okay, and so it's a very efficient way of integrating UAV data with your survey data. It's very, very efficient from a time standpoint, in that we've already finished adding in our ground control points. And so this is the last GCP that might be visible. There's only one appearance. I'll say I'll skip this one, okay? And I'll click on finish. So you can see here that there's a summary of the ground control points that I clicked on and the ones that I didn't. And if you remember, in this project, I uploaded like 25 ground control points, but only 4 or 5 of them were visible in these images that we processed live, okay? So I'm going to click on the upper right-hand corner here, apply corrections, and it's off and running again, okay? So now, once you've applied those corrections, we're going to readjust the photogrammetry data, and we're going to start creating the dense point cloud and all of the other different data products that are available, okay? So that's gonna process while we're on this web demo. You can see here that it's at 30% already. I'd like to switch over quickly and show you a couple things before we go back to Nathan. So while this is processing, let me switch back to my sites page. Okay, so I want to quick show you a feature that we just released today, actually. So I'm going to click on this project or this site called Day 1. And you can see here that in this folder, I have 2 projects, and I've called one Day 1, the other Day 2. Okay. So what's interesting here is that we have 2 data sets that were collected on different days over the same location. And so what we can do is we can group them together in the same folder. And if I click on Day 2, if I go down here to 2D viewer, you can see here that I have a timeline at the bottom. So for instance, if you're doing a construction site and you're flying it once per week or once every couple weeks, all you would do is every week that you fly, you would put that project into that folder, the same folder, and then you'll get access to this timeline feature here at the bottom. So now, one thing you can see here is that there's a slider. So as you move this across the screen, you can see the changes that occurred from day to day. And I can turn off different parts of that. So if I turn off, for instance, the DEM, I'm going to turn that off. And I'm just going to look at the ortho image. So you can see here that, oh, you know, this car moved in there on this day. In this particular instance, if I was looking at the DEM, the actual piles didn't change significantly. They weren't moving them around. But if they were, you know, you could look at those differences from week to week. So it's just a way of sort of, you know, taking a new approach to looking at projects where you might be flying the drone at that site continuously on a weekly or monthly basis. It's a really easy and intuitive way to visualize that data from different time periods. Now let me go back to our sites. And we'll go back to our test project. So you can see here that all of these data products you should be able to download. So let me show you an example. So our motto is, for every product we produce, we want it to be visible in the web browser. So we want you to be able to see it, but we also make it available for download. So in the case of the dense point cloud, you've got LAS and PLY file formats. So you can just download these directly, bring them into P3D, and be off to the races. Okay, so all of your data products that you create are downloadable, but they're also viewable in the web browser should you want to, you know, share a 3D model with a client, for instance. So anyways, that's a quick overview of some of the features. I'll let Nathan take over from here because I know he wanted to show off some P3D features as well.
Thanks, Ben.
Yeah, feel free to comment, Nathan, if you think I've missed anything.
No, I think you hit all the high points, and I even saw some new stuff today myself. It's fantastic. All right, now I think Mark's going to take us through doing some point cloud editing and fixing up. So maybe do some pile volumes and some cleanup, and maybe show us how to make a surface from one of these drone surveys. So
I will.
take it away, Mark.
All right, thanks, Nathan. Thanks, Ben. Let me show my screen. So here we are at this quarry site. I've already got it in P3D and looking at the dense point cloud. What I had done, and I'll basically I'll just delete this one and show you guys. I'm going to load the point cloud. It came out with 15 million points. Okay, I don't necessarily need 15 million points. So what I'm going to do is I'm going to thin this cloud. So instead of loading all 15 million, I'm going to load point number 1, point number 10, point number 20, and so on, or kind of in a nutshell, 10%. And that's my goal here, because I'm setting my projection to Michigan South, okay, by setting projection manually. And then I'm going to come over here, finish command, and now you'll see the point cloud that came from Carlson PhotoCapture is being loaded into P3D. And so here we go. So here we are at the quarry. We can start to rotate around. You can see we've got a conveyor belt, things like that in here. We've got some other junk in here at the time, a truck and maybe a trailer or something over here. Just in its basic form, I think I'm going to show you guys basically how you can thin this point cloud and get rid of a truck pretty simply. For this, I'm just going to draw a polyline. I'm going to click, point, we'll come around that thing too. I don't know what it is. Click and C for close, just like our CAD software. So you can see in there, there's some sort of vehicle there, but we're going to limit the thinning of the cloud to this polyline. That's why I drew it. Okay. So I'll click on my point cloud. I will come to my filter point cloud tool. I will hold down the control key, right click, and select this polyline. And then by setting parameters for the bare ground filter, and for this one, I'm just going to do 10 with a maximum height distance of 2. Apply the bare ground filter, and we'll see what the results are. So if you rotate around, you can see that I thinned and took the car out of that point cloud by isolating it with a polyline. Now, I could have done this for the entire 13 acres if I wanted to. There's a lot of times you may not want to do that. And you want to look at it from individual positions. You know, let's just get rid of this for the time being. Come over here, get rid of some of this junk, trees, things like that. The next thing I want to show you is how would I need to do a volume of this gravel pile. But you can see I've got a conveyor system in here that's causing me a headache, right? Because if we did a surface model here, the surface model would include a conveyor belt. That's not gonna that's gonna throw our numbers off. So what I want to do is by selecting the Michigan Quarry colors, I can come here to this command that's called isolate points. This is one of the
command first.
Yeah, thank you, Nathan. Finish my command for removing the car. So if I select this polyline here, what it does is it kind of gives me a rubber band to trace around certain points that I want to isolate, remove, things like that. So I'm just going to start clicking, getting at a good angle. I can adjust this as I go. Coming down through here, maybe get some of this, get down here, come across, maybe get up like that, and surround that entire set of points in the conveyor. I can say keep enclosed in selection. And it will go through and it looks at the point cloud and it selects the points. But you can see that it's removing points over here that I may not want to remove. So I can come back in here and I can run this command again. Just get an outline around the area. I'm going to miss a few points on this guy and remove from the selection. See, get these over here too while I'm at it. Oops, I think I missed the spot. Remove from selection. Being remove from the selection. And now I'm starting to work over here with conveyor belt and things like that. And as you rotate it around, there's some points I could leave, but I just want to stockpile of this. I see the toe. So I'm just going to say, you know what? Let me make a new cloud from the selected entities. Okay? So what I just did was instead of deleting those points in the conveyor belt, I made a whole nother point cloud from it. So now I could turn those on or off. See? And so now if I want to look at creating a stockpile or a volume report just of this gravel area, I can come here. We have a command called calculate.
Hey Mark, could you show us the, can we see contours directly in the point cloud?
Yes. From the point cloud. Color and elevation range. And so there you can start to see. Now this may even make it I think Nathan likes to see this because it really does point out the toe. You know, I can see it just visually, but we can leave it like this as well by changing from whatever, this is from the point cloud itself, the pictures, or you can see the contours and elevations like this. Now, if I leave it like Nathan likes, which is fine, you could come in here and do a volume calculation here. So what I get is it says select the top surface or a point cloud. Well, that's this guy. And now I'm going to draw a polyline. So I select this command and I can just start coming around what I think is the toe. In a nutshell, I'm not worried about being too crazy exact. All these points over here are about the same elevation anyway. It just really helps to make them stand out a little bit. There's some of the point area that we cropped out. Come around and hit C for close. And basically what happens is it comes in here and creates a volume of this stockpile. And you can see I've got about 3,500 cubic yards of gravel in this stockpile. Now I can click OK here. That data is shown over here where you can copy it and paste it in reports, things like that. I could turn off my point cloud and I can actually see the surface model of that as well, which is good for reporting as well. There's that little polyline from getting rid of the truck a minute ago. If I right click and just drag like you would in CAD, you can hit the delete key and get rid of that stuff if you want to. All your Windows keys like Control Z is undo, Control V, Control C, copy, Control Y, we'll redo, I think, things like that in order to see those. I turn the point cloud back on. Now I can, again, isolate this, make a picture of it, copy and paste this data, boom, pile one, stockpile. So there's that. I hear somebody typing in the background. I'm sorry. We'll go back.
Answer the question.
Answer the question. Thank you. And so now we can come back in here and we're still messing with the point cloud. If you want to, you could always merge this point cloud that we deleted back into the original one. If you want to, you can come in here and rename it, call it what you want to. This feature of making new point clouds of areas is very nice. I've seen it remove boats from projects along the Ohio River where you may want to keep the boat because it was flown, but you don't necessarily want it in your surface model, so you can do those things. Is there anything else that you would like me to show, Nathan?
No, I think that you've shown the bare ground filter, at least an example of it, a small example, which works really well against trees and vegetation. And
it does.
And the nice thing about our point isolator and the way that you can split clouds up and work by polygon areas is that you can do more aggressive processing in areas where you have a high density vegetation. You can get more aggressive, to clean the cloud up in there, but then be less aggressive where there's not any noise or vegetation, so that you maintain a higher degree of accuracy. So we have a really good, easy to use mix of tools to allow you to pretty quickly go in there and do just exactly that. And then And for each one of these volume surfaces or finished surface topo models that you create in here, you can save them. You can export them out as a land XML surface file or a Carlson TIN file or a TopCon or Trimble surface files as well. You can also import all of those kinds of surface files in here, because the neat thing about P3D Topo is once you create the surface model, we have a huge selection of surface editing tools. So you can add break lines, you can import additional survey data, and we have a field to finish feature where you can automatically draw polylines, on the top of bank, bottom of bank, top and back of curb, and then add those as break lines to your survey. So you can not only do your drone survey, but if you pick up some important points, break lines, you can also bring those into P3D Topo after you process the aerial drone photogrammic cloud, and then you can add and augment and increase the accuracy of your surface model in P3D very quickly and simply. And then you right-click on it, save it, export it as a Carlson TIN or land XML file, take it back into your CAD software of choice, and create your contour maps or create your finished reports. And we did have one question on here that asked about is there a report given on the accuracy and precision of the photogrammic analysis in PhotoCapture? And the answer is yes. So one, there's a bundle adjustment report that's very detailed. And then also at the end, you'll note there's a project report that is full of all your statistics of, from the bundle adjustment itself and the accuracy.
Hey, Nathan.
Yep.
I'll just quick chime in here. So the bundle adjustment report is still there. We did temporarily disable the project report because we're giving it a bit of a facelift at the moment. But all of the relevant statistics involving the accuracy of the bundle adjustment, like the fitting of the photogrammetry with respect to the control points, the ground control points, all of that is included in the bundle adjustment report. And if I can quick hijack the screen here.
Hold on 1 second, Ben, I'll get you.
Okay.
Oh, you've already done it. Go ahead.
You can see here that, so here's our project that we started, when we began today in this webinar. And you can see here that all the data's already been produced. It's available for download. You can view it. And here's that bundle adjustment report I was talking to you about. But the point is that, here we are, we've been doing a webinar at the same time as we've been processing data, and all of this is running in the background. So what PhotoCapture does really well is it sort of frees up your desktop, where you can be working on other projects while your photogrammetry data gets processed, and so you get rapid turnaround time. You don't have any backups with respect to computers. So it's a very easy and intuitive way to process imagery data.
And apparently works on old dusty laptops.
Although the visual, I actually the last time I opened this computer was late 2016. So, but yeah, it still worked.
Yep.
All right, so I think we've gone through here. I'll see if there's any additional questions in here. What file formats are ortho mosaics downloaded? Max file size is allowed it. So if we go to the digital or the ortho image and look at the download options, certainly GeoTIFF, JPEG with world file. What are your other options on your ortho image download options?
It's mainly GeoTIFF and JPEG. But to answer your question, what we do is once the ortho image gets above a certain size, it gets tiled. Okay, so when you download it, instead of downloading a 200 or a 100 gigabyte ortho image, what we do is we tile it into smaller ortho images so that you can load them into CAD and it won't crash the program like it would if you potentially loaded in a full resolution, not full resolution, but the full image at once.
Which is a common problem. Precision 3D Topo has some specialized handling software. So if you happen to have those 1 GB plus ortho images and you need software to bring them in and view them and work with them, drape them to surfaces and so forth, P3D Topo will work very well. Where a lot of software isn't well equipped to handle files of that size. We also could read Mr. SID files, JPEGs, GeoTIFFs, and I'm sure there's 1 or 2 other file formats in there as well. All right, so let's see if we have any other questions here. I think that's it.
Well, thank you all.
Yes, thank you all very much for attending.
If you have any additional questions, feel free to contact us. We're happy to help.
Yes, very much so. You know, you can get in touch with some of the local Carlson your sales staff, or directly to me, Nathan, or Ben. And I think our email is listed there. So.
Oh, we do have a couple more questions here.
I was just going to chime in quick, Nathan. I don't know if you guys can still see my screen.
I do.
Okay. In the bottom left-hand corner, if you have any questions, you can just start chatting with us directly. So, you know, if you get hung up on adding your ground control points, usually, unless it's, you know, 2 a.m. on a Sunday morning, you can get a hold of us right away. So, you know, that's another way of contacting us for support.
And there's one other question on the ortho viewer. So the ortho image can be shared directly from PhotoCapture. So it can be viewed on any device for free. So again, you can send a link to your clients, your customers, coworkers. They can open up the project, and then they can view the ortho image, the dense point cloud, the surface model, all in a web browser, whether it's on their smartphone or a tablet, Mac, PC, Windows, what have you. So so it's easy for other people to be able to access and see this data. And let's see, we said the pipe-looking button on the top. Let's see, so the pipe-looking button on the top is all about our hydrology module, if you saw that. And that will be the webinar on Thursday. So if you didn't know that, we launched a brand new P3D hydrology module that does watersheds, culverts, and storm sewer layout design. And we'll be giving a webinar on that on Thursday at 10 a.m. Eastern Standard Time. I think there's a link in the Carlson newsletter and the Carlson website if you want to attend that. But that's where the pipe symbol, that's what that's all about. It's all about the hydrology. Okay, looks like we've got all of the questions answered.
Awesome. Thank you all very much for attending. And again, don't hesitate to contact us if you need assistance.